Right, so question number 2, which of the following atoms in its gaseous state will liberate largest amount of energy when it gains an electron? So here they are talking about electron affinity in the gaseous state. So what is electron affinity? So when a neutral, then there is a neutral element, so it takes an electron while liberating a certain amount of energy. So when there is a element where its octet is completed, for an example here, neon. So here neon, the octet is completed. So if you want to put an electron to this neon, it is not easy because you are trying to break the stable configuration, right? So when you want to give an electron to neon, there will be not much of an energy that is released from the system. You have to give energy in order to put that electron into neon, right? So you can consider it that in that way. For an example, sodium. So you know that sodium, we have like S1 configuration. So in gaseous state, it quickly tries to get another electron and become 4s2, which is more stable now. So in this case, there will be higher number of energy that is given from the element. Here it is the other way around. We have to give energy to put the electron because the element does not like to get an electron from outside because it is already in the stable state. Okay, so you can understand here from the elements that given, if there is a configuration where a stable configuration is obtained, it would have a highest amount of energy that is given out to the system. Okay, and out of the elements, now this is also in a partially stable configuration. Sodium is okay. So sodium will have some amount of energy that is given out from the system because it is trying to get stabilized. And when you go to phosphorus, so you know lithium, beryllium, boron, carbon, nitrogen, phosphorus. So phosphorus is 8. So we have 1s2 2p4. For an example, if you think about this one, so there will be 1, 2, 3, and another one like this. Okay, if these are the electrons. So when you go to sulfur, you have sodium, magnesium, aluminium, which is 13, silicon, phosphorus, which is 15, and sulfur, which is 16. So you can imagine here nitrogen is in the 7, in fact, which is 7. So there will be no, this will be, for an example, 1s2, 2s2, 2p6, and then 3s2. This is not good, my writing is not good. So there is 3s2 and 3p. So when you have sodium, then magnesium, then aluminium, silicon, phosphorus, sulfur. Okay, so 13, 14, 15, and 16. So already there are 10, so up to 2p6. Then 3s2, there will be 12, and 3p3, so there will be 3 here in phosphorus, and there will be 4 here in sulfur. So this is also a little bit of partially stable state. So this will also not give much of energy to the outside. So these are not the things that you can imagine. So the only possible answers are these two, sodium and sulfur. So in these two cases, okay, so here, this is a P energy level, don't forget. This is an S energy level, okay. And here, when you consider about sulfur, it is in the same period, both sulfur as well as sodium. Okay, think about that fact. Now think about the electron affinity. Sodium is having a 1 electron in the s orbital, so it can accept an electron as well, or it can remove this electron and make it empty. So there are two things that is possibly happen as a probability, right, when you compare about sodium. And in fact, in more or less conditions, sodium in the gaseous state will be in Na2 state. It will be not in sodium form, because since it has 1 electron, it will be combining with another sodium atom and form Na2 gas. Okay, that is why this question is typically given as in the gaseous state, because if sodium does not form Na2 in the gaseous state, the sodium would have the highest amount of energy that can be given out, because this is an S. But here, since this is P, where sulfur is in P, when you compare sulfur and sodium, since sulfur is present as sulfur itself, but sodium does not exist in the gaseous state, it will be converted to Na2 gas. Okay, so it will be in Na2 form. So this is not easy case to give an electron now, because in the gaseous state, sodium is not in sodium, it will form Na2 gas. But however, sulfur, now you can see, you can either give 1 electron or either 2 electron. Anyway, if you give 1 electron, there will be energy that is given out, because it's happy to accept an electron from outside. Okay, so this is the explanation for this one. This is stable. This is also a little bit stable because of S2 configuration. This is partially stable, so you are remaining with sodium and sulfur. And sodium, in fact, it has only 1 electron, and sulfur, you can see there are 2 electrons that can be accepted to form the stable state, or either it can remove this electron to get stable. So you have sulfur and sodium, which can remove an electron to get stable, either partial stable or completely stable, giving an octet configuration. But sodium itself in the gaseous state is forming Na2 gas. So it's not that easy to give an electron to sodium in gaseous state. But sulfur, it is okay, still it can use some electron, 2 electrons in fact, to give heat energy outside. Okay, so this sums up our discussion.